Hello viewers, in today's session we are going to discuss an important result from three-dimensional geometry, and here we are going to derive the formula for the perpendicular distance of a point from a plane, right? So suppose we are given a plane, and let us denote this plane by the letter P, right? And suppose we have a point that is say A, whose coordinates are x1, y1 and z1, and here we wish to find out the perpendicular distance of this point A from this plane P, whose equation is given as ax plus by plus cz is equal to d, right? So any equation of this type in first degree is always representing a plane, right? So here we wish to find out the perpendicular distance of this point A from this plane P. So now let us drop a perpendicular from this point A to the plane, right? And let us take the point, this point, that is the intersection of this perpendicular and this plane P, as B, and B is the foot of the perpendicular, right? And AB is perpendicular to the plane P, right? So here we have 90 degrees, and let us draw the normal to the plane, and this normal is denoted by the vector n, right? So here n vector represents the normal to this plane P, and AB is the perpendicular, right? So here we want to find out the formula for this length, that is the perpendicular length, that is AB, right? And here we note that AB is parallel to the normal vector, right? So this perpendicular AB is parallel to the normal vector, and the direction ratios of the normal vector are given by the coefficients of x, y and z. So the direction ratios of the normal vector are given by a, b and c, right? And when AB is parallel to the normal vector, then the direction ratios of this perpendicular AB are proportional to the direction ratios of the normal vector, because whenever two vectors are parallel, their direction ratios must be proportional. So we can take the direction ratios of this perpendicular AB as say a lambda A, lambda B and lambda C, where lambda is some real number, right? So when we take the direction ratios of this perpendicular AB as lambda A, lambda B and lambda C, then these ratios can again be written as A comma B comma C, right? So now we can write the equation of this perpendicular AB, that is equation of AB can be written as x minus x1 over A, then we have y minus y1 over B and z minus z1 over C, right? So this is the equation of this perpendicular AB, where this AB passes through this point x1, y1, z1, and the direction ratios of AB can be taken as lambda A, lambda B or lambda C, or simply A, B and C, right? So now let us find out the coordinates of the general point lying on this line AB, right? So here we wish to first find out the coordinates of this point B, which is the foot of the perpendicular AB. So let us take here lambda, where lambda belongs to the set of real numbers. So let us form three equations. that is x minus x1 over a is equal to lambda, y minus y1 over b is equal to lambda, and z minus z1 over c is equal to lambda. So from these three equations, we can now write x is equal to a lambda plus x1, and y is equal to b lambda plus y1, and z is equal to c lambda plus z1, right? So x, y, and z represents the coordinates of a general point lying on this line AB for some value of lambda, right? So for some particular value of lambda, this coordinate, that is a lambda plus x1 comma b lambda plus y1 plus c lambda plus z1 represents the coordinates of this point b, right? So here this point b can now be represented by this coordinate a lambda plus x1, then we have b lambda plus y1, and c lambda plus z1. So now see here, this point B lies on this line AB, and this point B also lies on this plane P, right? So therefore, this coordinate must satisfy the equation of the plane, which is AX plus BY plus CZ is equal to D, right? And ABC represents the direction ratios of the normal to this plane P, right? So this point B satisfies the equation of the plane, that is equation 1. So let us substitute this coordinate, that is the values of x, y, and z in this equation. So we can now write a times a lambda plus x1, then we have b times b lambda plus y1, then we have c times c lambda plus z1 is equal to d. So let us solve this equation, right? So we have a square lambda, then we have ax1, then we have b square lambda, b times b, b square, then by1, then we have c square lambda plus cz1 is equal to d. So let us collect the terms here. So we have a square lambda plus b square lambda plus c square lambda, and then we have these terms, that is ax1 plus by1 plus cz1 is equal to d. So let us take lambda common. So we have a square plus b square plus c square, and then we have ax1 plus by1 plus cz1 is equal to d, right? So let us write this equation as a lambda a square plus b square plus c square, and then we can take this term to this side. So we can now write a minus, and we have here ax1 plus by1 plus cz1, and here we have a minus d, right? So taking this term to the right hand side, and then taking a negative sign common, we can now write this equation like this, because when we multiply these two terms by this negative sign, then we have negative of ax1 plus by1 plus cz1 with brackets, and then a minus, and minus becomes positive, that is here we have a plus d, right? So let us write now lambda is equal to minus, then we have ax1 plus by1 plus cz1 and minus d divided by a square plus b square plus c square. So now let us find out the distance between A and B using the distance formula. So the distance formula is given by square root of x2 minus x1 whole square. Then we have y2 minus y1 whole square, and then we have z2 minus z1 whole square, right? So let us take this coordinate as x2, y2 and z2, and this coordinate is x1, y1, z1. So we can take the coordinates of this point B as x2, y2, z2. So we can now write AB is equal to square root of x2 minus x1. So x2 is a lambda plus x1 minus x1 and square. Then we have b lambda plus y1 minus y1 square, and then we have c lambda plus z1 minus z1 whole square, right? So we can now write AB is equal to square root of here x1 and x1 get cancelled, y1 and y1 get cancelled, z1 and z1 also get cancelled. So we have a lambda square, then we have a b lambda square, and then we have a c lambda square. So we can write square root of a square lambda square, b square lambda square, and c square lambda square. So let us take lambda square common. So we have lambda square is equal to a square plus b square plus c square. So now we can write this expression as square root of lambda square and square root of a square plus b square plus c square. Now square root of lambda square can be written as the absolute value of lambda, right? So we have here absolute value of lambda, and square root of a square plus b square plus c square can be written as a square plus b square plus c square raised to half. So the distance between a and b is given by this expression, right? So we have the value of lambda given by this expression. So let us take it as equation number 1, and this is as equation number 2. So let us substitute this value of lambda in equation 2. So now AB is given by absolute value of lambda, and lambda is negative of ax1 plus by1 plus cz1 minus d, and then here we have the term that is a square plus b square plus c square, and then here we have the term a square plus b square plus c square raised to half, right? Now here we have the mod of this term, and here we have the negative sign, right? So this mod sign makes this negative sign positive. So we can now write the absolute value of simply this sign becomes positive. So we have ax1 plus by1 plus cz1 and minus d, right? And since this is a positive term, so this term may be taken outside this mod sign. So we have simply a square plus b square plus c square raised to 1. And here we have a square plus b square plus c square raised to half, right? And here we can see that a square plus b square plus c square, and here also we have a square plus b square plus c square. So let us take this term to the denominator. So we have mod of ax1 plus by1 plus cz1 minus d divided by a square plus b square plus c square raised to 1 minus half. So taking this term to the denominator, we have here a negative sign, right? So we have 1 minus 1 over 2. So here simply applying the laws of exponents, we can now write mod of ax1 plus by1 plus cz1 minus d divided by a square plus b square plus c square, and 1 minus half is simply half. So we can now write here the radical sign, that is the square root, right? So this is the required formula for the perpendicular distance of a point x1 y1 z1 from this plane P, whose equation is ax plus by plus cz is equal to d.